Okay, this is the new unit in geometry. The unit is called Transformations. It's Unit 3. And this first lesson I'm calling Transformations. I'm calling it Rigid Motions and Translations. That'll be the main focus of the lesson. Okay, so the unit again is called Transformations. This first definition, that's called transformations. Let's see what a transformation is, okay? A transformation is a function that changes the position, shape, and or size of a figure. The original figure is called the preimage. And the resulting figure is called the image, okay? So you start with the preimage, and then you perform the transformation, and you end up with the image. Okay? This next definition is called an isometry, also known as a rigid motion. So I'm going to put both definitions. An isometry, also known as a rigid motion, is a transformation in which the preimage and the image are congruent, meaning they're the same shape and the same size. That's called an isometry. The four main types of transformations we're going to do are translations, reflections, rotations, and dilations. And the first three, translations, reflections, and rotations, those are all rigid motions. So example 1, does the transformation appear to be a rigid motion? Explain. So 1A, this is not a rigid motion because the preimage and image are not congruent. I'm going to say no. There is a change in size. Okay. In other words, the preimage and image are not congruent. Okay. Example 1B, yes, this is a rigid motion because the preimage and image are congruent. They're the same shape and the same size. So yes, the transformation is a rigid motion. I'm just going to say because the preimage and image are congruent, okay? Because the preimage and image are congruent. Okay. Here's this next thing. A transformation maps a figure, the preimage, onto its image, and it can be described with arrow notation. Okay? Prime notation is sometimes used to identify image points. Okay? So that's the prime symbol. So the figure that has the prime symbols, that indicates the image. So if you look, this is A, B, C, that's the preimage. If you look, you have A prime, B prime, C prime, that's called the image. Okay? So the figure with the prime symbols is the image. Okay? And this is how you may see it written. This is called arrow notation. And that's read maps onto. So this is read A maps onto A prime. Okay? This is read triangle ABC maps onto triangle A prime, B prime, C prime. Okay. Example 2. in the diagram, triangle NID maps onto triangle SUP. Part A, name the images of angle I and point D. Okay. So part A, the image of angle I is you just have to be careful. The order is very important, okay? I is listed second in the pre-image, so that maps onto U because that's listed second in the image. So the image of angle I is angle U. Okay? And the image of point D, which is the other part of the question, is, well, D is listed third, so its image is P because P is listed third. So the image of point D is point P. List all pairs of corresponding angles and sides. Okay, part B. Let's start with the corresponding angles. And then we'll do the corresponding sides. Okay, so the corresponding angles, let's start with N. N and S. Those are corresponding because they're each listed first. This is going to be really important for the rest of this unit and the next two units. N and S correspond. They're each listed first. Same thing with I and U. Angle I and angle U, they're corresponding because they're each listed second. And then angle D and angle P are corresponding because they're each listed third. Okay? For the corresponding sides, you can either look at the diagram or let's look at the original given information, okay? NI, that's listed first and second. NI corresponds with SU because SU is listed first and second. Okay? ID, second and third. That corresponds with UP, second and third. And then ND, first and third, corresponds with SP, first and third. Okay. This next definition, that's called a translation. We're going to focus on translations for the final page and a half of these notes, okay? A translation is an isometry. In other words, it's a rigid motion. In other words, the pre-image and image are congruent. So the pre-image and image are the same shape and the same size, okay? So it's an isometry that moves all points of a figure the same distance in the same direction. It moves all points of a figure the same distance in the same direction. It can be thought of as a slide. Okay? So example 3, write the translation rule for the translation below. So here's how I'm going to do it. I'm going to say XY maps onto, and you just have to be careful. We're going from A to A prime. Okay? Okay, you have to be careful. We're going from A to A prime. A to A prime. So you're going to count from A to A prime. You're going left, 1, 2, 3, 4, 5, 6, and you're going up 1, 2. So you're going left 6 and up 2. So the way you're going to write that is if you're going left 6, you're doing x minus 6. And if you're going up 2, you're doing y plus 2. And that is my answer. That is my translation rule. This is saying xy maps onto x minus 6, y plus 2. And the same thing for B and C. Okay, so if you look at B and B prime, to get from B to B prime, you're going left 1, 2, 3, 4, 5, 6, up 1, 2. And to get from C to C prime, you're going left 1, 2, 3, 4, 5, 6, up 1, 2. Okay. Example 4. The translation image of triangle LMN, which is graphed below, is L prime 1, negative 2, M prime 3, negative 4, and N prime 6, negative 2. Write a rule to describe the translation. Okay, so let's start with L. What are the coordinates of L? It's negative 6, negative 1. Let's look at M. What are the coordinates of M? It's negative 4, negative 3. Let's look at N. What are the coordinates of N? It's negative 1, negative 1. And you don't have to write all this out. I'm just doing it out for now. L is going to L prime, so I'm just going to copy that. Again, you don't have to write this. M is going to M prime, which is 3, negative 4. That's given to me in the directions. And N is going to N prime, which is 6, negative 2. So the question is, what is the rule? You have to write the rule. I'm going to say XY maps onto. You have to figure out what the rule is. So let's focus on the X's first. Let's focus on the X's. To go from L to L prime, you're going from negative 6 to 1. That means you are adding 7. And let's just verify that with M and N. So for M, you're going from negative 4 to N prime, which is 3. So again, you're adding 7. For N, to go from N to N prime, you're going from negative 1 to 6. So again, you're adding 7. Good. Now let's do Y. Let's look at the Y's now. Let's start with L. You're going from negative 1 to negative 2. So it means you're subtracting 1. And let's double check that with M and N. So for M, you're going from negative 3 to negative 4. You're subtracting 1. And for N, you're going from negative 1 to negative 2. You're subtracting 1. So this is my answer. That's my translation rule. Okay. All right. So one more example. And then we're done with this lesson. Graph the image of triangle RQS under the translation XY maps onto X plus 3, Y minus 8. Also state the coordinates of the pre-image and the coordinates of the image in the table provided. So this one wants you to graph the image, and it wants you to fill out the table. So when you fill out the table, here's how you're going to do it. I'm going to put the XY maps onto rule in the top row of my table. And then I'm going to go in alphabetical order. I'll do Q, R, S, maps onto, maps onto, maps onto, Q prime, R prime, S prime. So let's just fill out the table first while I'm here. Okay. Q, the original Q is at 1, 1. That's going to map onto 1 plus 3 is 4. 1 minus 8 is negative 7. R is at 1, 8. So that's going to map onto R prime. 1 plus 3 is 4. 8 minus 8 is 0. 4, 0. S is originally at negative 2, 0. That's going to map onto S prime. Add 3 to the X to get 1. And subtract 8 from the Y to get negative 8. Okay? So that's my table. And now you can actually just graph those if you want. The other thing that you could do if you want to graph it is you could take each point and just count right 3. So count right 3 and down 8. Count right 3, down 8. Count right 3, down 8. You could physically do that if you wanted to, okay? So just to show you that with Q, I'm going right 3, 1, 2, 3, down 8. So down 1, 2, 3, 4, 5, 6, 7, 8. Which is the same thing I got when I did this table earlier, okay? So again, R prime is going to be 4, 0. You can either just go base off your table, or you can take R and actually count right 3, down 8. So if I do that, right 3, 1, 2, 3, down 8, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And let's do S to get S prime. So let's go right 3, down 8. Right 3, down 8, we're going to be right there. It was supposed to be 1, -8. Anyway, so 1, 2, 3, 1, -8 right there. Okay, right 3, 1, 2, 3, down 8. Let's connect those. Okay. If I can get my ruler out. There you go. And then after we connect them, we're going to label it. Let's label our vertices. And don't forget to put the prime symbol. So we got R prime right there. We got Q prime right there. And we got S prime right there. Now keep in mind, we are doing translations in this lesson. Translations are always rigid motions, aka they're always isometries. So your pre-image and your image should be congruent. They should be the same shape and the same size. If they're not, then you know you made a mistake, okay? And that is the end of this lesson. This was Unit 3, Lesson 1. The lesson was called Transformations, Rigid Motions, and Translations.